Hello friends, my name is Shiv Singh and welcome back to our channel bianddataScience.com. In this video, I am going to walk you through how to download MySQL Workbench, and we will also download some sample data sets and we'll do some hands-on exercise. So don't go anywhere, I'll be right back after a very short intro. Okay, friends, while we are back, what you need to do first, you go on Google and you need to type MySQL Workbench. And when you type MySQL Workbench, you'll go to this MySQL websites where it says MySQL Community Download. Now you will select just download without registering and the file will be downloaded. Once the file is downloaded, all you have to do is you have to go and click the installer here and the 64 MSI installer will start downloading. Now friends, it is important to remember when you are downloading the installer from the MySQL community download, the latest version of MySQL server is 9.2. I recommend do not install 9.2 because it does not support your MySQL client workbench. There are two components. One is MySQL server, which is responsible for creating the database, storing the database, and any query that you write executes on the server. But at the same time, to write query, you can either write the query on the shell prompt, which is a command line instruction, or you can write the query on the GUI interface, that is the SQL workbench. So when you are going to download the MySQL Workbench, the MySQL Server 9.2 is not compatible with that. So you will run into challenges, the software will crash. So be careful, do not download MySQL Server 9.2 for now. It's a beta version, it's only for testing. So what you need to do instead is you need to instead go and download the version. So instead, what I recommend you to do is go. Okay, so you go here and you type MySQL Workbench. And when you type MySQL Workbench, just click no thanks, just start my download, and you will see the MySQL installer like this. Now in this installer, you will be able to download the workbench along with MySQL. So you see here in the checkbox, you have MySQL Server 8.0.4. So 8.0.4.1, that is a good latest working model. I highly recommend you download the server version 8.0.4, and you see you'll get the SQL Server along with the MySQL Workbench and the shell, and you see this at the bottom you have samples and examples. So it is necessary, it will give you a lot of sample database tables that we are going to do hands on today, and you can download all of them as a bundle so you don't have to upload the database manually. So I highly recommend you check that option, and then you just have to click execute. Once you click execute, the installation will begin. You just click next. While it's installing, it will ask you to assign the accounts and role. When you are prompted to an authentication method, while installation you will be prompted to give authentication method. So choose the strong encryption method, the recommended one, and then click next. And after you click that next, you will be asked to define the account and roles. You can create one admin account which would be responsible for accessing the MySQL database and instance, and you'll be able to do all the modification. And then later on you can add users, you who have only user level role, right? So go ahead, choose a password and then select enter, and then next and next, and you will be done with the installations. Here you click to the apply configuration. When you open SQL Workbench and when it asks you to set up a connection, all you have to do is you have to give your local host, or if you don't want to give local host, just type in 127.0.0.1. That is the synonym for local host. And once you select all of that, your console will open. Now you can go and once you are connected to the server, you can click on database and you can click on the schema here. Besides this administration, your tables would be visible here in the schema. So now you can see you have tables Sakila. Sakila is the database where we will do a lot of hands-on exercise today. Then you have the sys database and you have the world database. World database is also very good. It has a lot of demographic information, and if you want to exploration on that, probably you'll be able to. So you're all set. What we did was we downloaded the SQL Workbench, we downloaded the server version 8.0.4. Then we also downloaded the Workbench, which is the client interface to connect with the server. All we are doing is we are writing our query in the Workbench, which is the client, and then our query are executed at the server. Now you have also downloaded 3 sample datasets: the Sakila dataset, sys dataset, and the world database. Let me walk you through the example of Sakila sample dataset guide from MySQL website. The file will look something like this. Now it has every notes around the legal notice, introduction. In section 5 you can see in a structure it lists down all the tables, views, stored procedure, stored functions, triggers. We'll talk briefly about what procedures, functions, and triggers are. But for now, I would say just scroll to the section 5. And in section 5, you can see it describes all the table and all the columns inside the table with a brief description of what those columns are. For your convenience, what I did was I took the sample database documentation and I did little bit of cleansing around it, and I created my own version of a summary. And the document that I created and that I'm sharing here in this video is linked in the description. All you have to go and click the link and you can download all the notes. You can download the sample queries that we are going to write, so that if you want to just copy paste those queries in your SQL window, you can do that. So all the materials are available free to you. Just all you have to go is in the link and click on the link, sign up by providing your email address. You can download all the documents free. Let me briefly walk you what the Sakila table structure is. So here on the screen, if you see, of the 16 tables, there are total 16 tables. So we have 1, 2, 3, 4, 5, 6 table on this page, and then 7, 8, 9, 10, 11, 12. You have additional 6 table here, and then you have additional 4 tables here. Let's understand what the Sakila database is about. So the Sakila database is about a film rental business. Think of it as an online rental shop where you can go and you can rent a DVD, and the DVD will be about any movie that's released or produced, right? And then customers are renting from certain stores, and after watching it, they are returning it to the store and they are paying a premium, or they are paying a rental fee for having that CD for certain number of days. First table, the most important table before going into the rental business, the crux of business is the movies, right? The films. Now, film table is a list of all films can be in a stock or in stores, right? Whatever film can be in store, it's a comprehensive list of all those films. You have film ID, it is a primary key. Primary key are unique, right? So it's a unique value. Now see here this word surrogate primary key. What does the word surrogate primary key means? Surrogate means it's a artificially created. So it's a integer like created using an algorithm so that it generates a unique value for every transaction or for every record. By film ID, we can uniquely identify any movie. These are all different attributes of the movie. So you have the title of the movie, You have the description, like what's the summary, what's the plot story, whether it's an action movie or it's a drama or it's a comedy. So you have all those very short description of the plot. Then you have the release year, in which year the movie was released. Language ID is the language ID that you will watch the movie, and original language ID is original language in which the movie was created. So, for example, the original language ID can be an ID for English. Actual dubbed can be Spanish or Hindi, or it can be any language, right? Then you have the rental duration, which is the length, how many days you are renting this DVD for. The rental rate, this is what you need to pay if you rent for this duration. Length, this length is the length of the movie. It's the movie duration in minutes. And replacement cost, that you will be charged if the CD is damaged or lost by you. So if you don't return it in time, either you will pay a fine or you will pay a replacement cost. Now you have rating. These ratings are very important because a movie can be universally viewable for all the audience, or it can be restricted for 13 years and older, or it can be restricted for 18 years and older. So these are rating. Now G is general rating, which everybody can watch. PG is where parent guidance is required. So if there are kids, they have to watch in presence of the parents. PG 13 means only 13 and over 13 years of kids are allowed to watch it. And R is restrict. NC 17 is not. It's kind of anyone who is less than 18 year should not watch. All the famous Hollywood movies would be either PG or PG 13, where you have some mild violence, some mild dialogues, and some nudity, but with parental guidance, kids can watch it. Special features are like if the DVD has commentary or not, last updated, like when was this updated, right? So you can see the film table has comprehensive information about the film. Table would be joined by different other tables because, for example, look at the film actor table. Now, film actor table has the information about what different actors have acted in that movie. So here you have an actor ID, film ID, and when that table is when that row is updated. So it is a many to many relationship. So film actor table, one actor ID can work in many different films. Actor ID can have many film ID because he can act in different films, and at the same time, one film ID will have many different actors because there are lead actor, side actress, lead actor. You can see both of them are foreign key. Like the film ID can be joined in particular film movie, and the actor ID would be joined with the actor table here. So in actor table, you have the complete information about that actor or actress. So here you see the actor ID is the primary key. Here it was foreign key because it is linking to the other table. Now primary table is primary key is in the table where it cannot be duplicated. So actor ID can only have one value for one actor in this table, right? Because in this table we want to uniquely identify all the actors. So for every actor ID we have their first name, their last name, and every actor will have just one record. But this is a primary key table, and in the film actor table, actor ID is called as the reference key because you are referring, you are joining, this column is referring to this table. That's why it's called reference key. This is how tables are joined. And then you have the film category because a film can be part of many different categories, right? It can be action, it can be drama, it can be in many category, right? So you have this category ID, whether the film is action or thriller or drama. So here you can see a film can be action and thriller, it can be suspense drama, or it can be comedy, or it can be suspense comedy, right? So a film can have different category. And then here in the category table, you have the name of the category, and the primary key is the category ID, and the name defines a category. I had put all the film related information on that slide. Now this is why it helps you visualize. here, because when you look at the documentation, so it will be very difficult to relate the schema of all the tables and how they reference other tables. You can comprehend it, but I tried to put all the related tables on one page so that you can easily establish the relationship. Now, this is more on the business side. So though the earlier slide talked about the attributes of film, actors, categories, and all of that, the language, here you have the business side of it, how the renting is happening. So here you have an inventory table, and in inventory table we are saying what film ID is in what store ID and what is the uniquely identified name for that particular inventory. So inventory ID you can think of as a SKU. If you work in consumer packaged good industry or in retail industry, you will hear this word SKU many times. SKU means stock keeping unit. It's nothing but just a way of understanding one item uniquely. In retail, the 50 ml of shampoo versus the 200 ml of that shampoo and 500 ml of that shampoo. These are all three different SKUs. Even though the product is same, but the SKU is one unique item. You have inventory ID, which is nothing but your stock keeping unit, then the film ID associated and the store ID associated. Now, in the store table, you have the information about the store. So you have the store ID, the manager in that store ID, and the address of that store, right? So by connecting with inventory ID and store, we can know what are all the inventory that a particular store carries in real time. In the rental table, you have the inventory ID. So one particular stock keeping unit that we talked about, what's the rental ID associated with it? Because every time the same movie can be rented by different people, right? So every transaction is uniquely identified by rental ID. So here you think of rental ID as a transaction ID. On what date that rental happens, what inventory, by what customer, what is the return date for that transaction, and what is the staff ID. Staff ID, you can see which person in the store. Now this, you can connect staff ID in the staff table. There you can know the first name of the staff, last name of the staff, address, picture, email, store ID, right? You can know all the different details about that staff. Which staff gave that inventory to which customer for how many days. All that information is in your rental table. So main business transactions are recorded here. All your business transactions are recorded in your rental table. Just like you join the staff ID in the staff table, you can join the customer ID with the customer table. Now customer table has all your information about the customer. Customer's first name, last name, customer's address, customer's email address, whether the customer is active, he is actively renting or not, right? All of that information. Once customer returns the rental, then he will pay. So all those payment transactions are stored in your payment table. So in the payment table, you have the payment ID, which will be associated with the rental ID, because for one rental ID there will be one payment ID, and which the customer and which staff took the payment, what was the amount, on what date the payment happened. So you can see you have a film table, you have all different foreign tables where you can attribute different components of movie, like what actors, what category, and so on. Then you have inventory, and that inventory will be associated with a store, and it will also be associated with a transaction. And in the rental table, which is recording all the renting activities, you have a customer association, like which is the customer that is renting it, and when the customer is returning the rental, you have all the records captured in the payments table. So this is how the business is happening. Now you should have a fairly good idea about the business. These are auxiliary tables, like all the address of the store, the staff, and customer. That's all stored in the address table, because whether it's a customer address or it's a store address or it's an employee address, every address had an address ID, and every address ID has a record here. So here address ID is the primary key. It can uniquely identify each address to whom it belongs, and based on which table it is coming from. If you join the address ID with customer, you'll get the customer's address. If you join the address ID with the staff, you'll get the staff's address. If you join it with the store, you'll get the store address. Languages, we saw in the film table, there was movie language and also the original language. So there we only had the ID. Now the name of that language is here, the English name of the language. Then similarly in address table, they have put an ID for the city, and city has the country ID, and the country ID has the country name. Coming back to question, when you think, why can't we have all this information in one table rather than having in different tables? Think of this. This is a rental table, right? This is your main transaction table in which a customer is renting one particular DVD or one particular inventory, and that's given by one staff, right? In this table, suppose if we started storing the whole information about the customer, like what's the name of the customer, what's the last name of the customer, what's his address is. Similarly, if we start writing all the information about the staff, or if we start writing all the information about the inventory, like what movie it is, what actor are in it, then all those information will keep on repeating. Like if the same customer is renting 5 times, the same customer information would be repeated 5 times. So it's a storage loss because you are storing the same data again and again. But you can say memory is cheap. I still want to duplicate. Then the challenge becomes is if any record, if the customer address changed, or if customer's information changed, now all you have, if you have to modify that customer information, you have to modify many different rows. A customer address was in this table. Then if that customer has rented 10 times and his address changed, for all those 10 instances, you'll have to go and update his address. Not only storage, but every time you do update or any modification, it will be redundancy, right? This is called redundancy. So remember in the part 1 of the video, we talked about the key properties of database. Our database has to have 4 properties: atomicity, integrity, consistency, and durability. So to maintain the atomicity, we keep the information separate so that you don't repeat the information. Now this process is called normalization, and it is a part of database design. You don't have to know as an analyst. Mostly the data engineer or the data architect would be doing it, but just know the concept, like why do we fragment the information in so many different tables? Because you as an analyst is doing more job, because if you have to say build a report where you want to show not only all the rental by a customer, but on a report you want to show the customer's name, address, phone number, along with all his rentals and the staff who gave him all those rental. So you might have to join the rental table with the staff table and the customer table. So you are doing more job while querying, but the logical cost of 2 things, I told you, right? In computer, everything runs on 2 things: memory, which is the storage, and the compute. The cost of compute and storage is still very low, because we will join it one time in cache memory, which will be fast. We are not storing it. We are not creating any redundancy, right? So any join during the query has a lesser cost, with exception if your tables are too fragmented. And for your daily analysis and reporting, if you start doing too many joins on a daily basis on a large data set, then probably the vice versa will happen, right? Then you run into more compute cost, because every time you are joining from different tables, so your compute cost will start going up. So that's why for analytics, what data engineers do is they create a view. And what they do in a view, they already join all the information from different table and create a join table for the analyst. And those tables are called as staging tables. So a lot of time as an analyst, you may refer to staging tables where a lot of information would be joined. Some level of duplicacy will be there, but you know these duplicacies are one time created, and they are created only at a presentation level. They are not at the storage level. They are created at a presentation level for you to not manually join the data every day and not incur too much compute cost. This is called the vice versa of normalization. This is called denormalization. So for analytics and data science, the data architects do some level of denormalization. But for business operations and actual storage, they have a normalization. They have normalized tables. It's a trade-off between the cost of compute and the cost of storage. So friends, this gives you a comprehensive understanding of the key tables in the Sakila schema. Now let's do some exercises, right? Friends, in part 1 of this video, in part 1 of our SQL, we had covered about what databases are, what are relational database versus no SQL database, why you should learn SQL, similarity of SQL with algebraic expressions, how do you subset columns, how do you filter rows based on cell criteria or based on the logical operations at a row level using and, or, and not. And we also talked about order by and limit clauses. So if you want to learn all those, I highly recommend you watch this video. The link is in the description. Friends, if you're thinking of making your career as a business analyst or data analyst in 2025 and you're still wondering what all to study, in what order to study, and from where to study, then don't worry. We have created a comprehensive roadmap. We have covered all different tracks. And for all this career, what are the things that you need to learn and in what order and in what time you can learn them? We have compiled all those information in comprehensive roadmap. The roadmap document is free. The link is in the description. Go ahead, download, and we wish you a very bright future in 2025. Your MySQL Workbench. You can see I have an instance of MySQL 9.2 which I downloaded, but it doesn't work very smoothly with the Workbench. So I recommend you don't download this version. Rather, you go and you download the 8.1.4 version, because we are going to write all the queries on Sakila database. What you would like to do is you can right click and you can set this Sakila database as your default schema. Otherwise, every time when you mention the table name, you have to type Sakila dot table name. Here you can see these are all the 16 tables that I briefly walked you and kind of gave you a little bit more understanding of what data is inside those tables, right? Say for example the film table, right, which was the more important one. Then you can say select star from film. Execute this. Either you can execute, you can select it and execute, or you can execute this line. When you execute, you see you have the film ID, which is 1 2 3 4 5 unique number, which is the primary key. Then you have the title, Academy Dinosaur, Ace Goldfinger, kind of, and you have a short description like it's a epic drama of feminist and mad scientist, right? Release year, the language, original language is not available, so it's null. Then rental duration, this movie is rented for 6 days. This is default renting is for 3 days. This is renting for 7 days, right? And you see the rate. You'll have different rates because the more famous demanded movie will have a higher rate and then the other movies will have a lower rate, right? This is the duration of the movie. This is 86-minute long movie. The Ace Goldfinger is 48 minutes long. And the replacement cost, if you lose the CD or the DVD, you have to pay $21 for Academic Dinosaur and $12 for the Ace, right? So this is your replacement cost. Now this is your rating, PG rating and all those. So now in part 1 of the video, what we had learned about how do you filter columns. Say for example, I only want to know the title and the release year. Then what I need to do is I need to specify them after the select clause, because after select we specify the column names separated by commas. So I need 2 columns, the release year and the title. So I type here title comma release year from film. So I'm doing nothing, but kind of I'm just filtering two columns. Now you see when I run the query, I just get two columns. I get the title and the release year. Now, then the third thing what we learned was how do you filter rows, right? Understanding a little bit about your ID. You remember in part 1 of the video I also told you your ID does not returns all the rows from. So here you're seeing the title and release year, but you can see here your ID is fetching only 1000 rows. Now there is a setting. You can go in the settings and you can in the file and in the settings. Yeah, you see here you can go here in query and you can say don't limit will pull all the rows by default every time. It's not advised. A lot of time your administrator will have it disabled because we are running a client in corporate environment. A lot of settings of your ID are controlled by administrators. They control. So most of the time it will be limited. We can also set it to just 100 rows every time. So suppose I want to know all the movies for PG ratings. So what I can say, select all from film where rating is equals to PG, right? Now this will give me all those movies that have PG rating. See, all the ratings for these movies are PG rating. So we can filter based on the rows. Now we can combine them. So for example, I want to get all the PG rating movies whose length is less than 100 minutes. Now, because I want to have movie PG rated along with the timing of less than 100 minutes, and they both have to be satisfied, I will use the operator AND. So I can say here AND the duration, the length is less than or equal to 90. Now if I run this, what I get is I get all those movies which have length less than 90 and are PG rated. What would happen if I would have used this as OR, not AND? So let me write the same query again here, but this time with OR. Just imagine what results you would get without running the query, right? So you will get a movie whose rating is either PG or the length is less than 90. So for other movies whose length is less than 90 and even if they are not PG rated, you will get those movies also. And you will get those PG rated movies whose length are more than 90. You will get both combinations, right? You can see it. See here. When you get 150-minute long, that movie is, this is PG rated and 150. Another example would be, I want to find all the movies whose rental is either $99 or $3, right? So for that I can write, so for example, I want all those movies whose rental rate is either $99 or $299. So I don't want $499. Then I can say here where rental rate, and because rental rate is numeric, we don't need the double quotes. We can say here rental rate is 099, or so this will give me all those movies which are renting for either $1 or $3. See, so I don't have any $4 or any other amount, right? So this is how you do basic query. You can select what movies, I can select what customer, what store, what movie is in what store. Like, so for example, I want to find all the inventory of store 1, all the inventory carried by store 1. So what I can go is, I'll have to go to the inventory table and I have to put a filter for the field of store ID. So I can say select star from inventory where store ID is equals to 1. Now this gives me all the inventory carried by just store 1. You can see store 1 is carrying all these film IDs 1, 4, 6, and they are having multiple copies of, but their inventory ID is unique. For the film ID 4, it's having 1, 2, 3, 4 copies, and the inventory ID for all the 4 copies is separate. So for one customer I can rent the inventory ID 16, to other customer I can rent the inventory ID 17, and so on, right? This is all. And friends, we have also compiled sample questions that you can query and you can practice yourself. If you want to get all those sample questions, they will be part of the notes. So in the description below, you can find a document that has all the notes, all the slides, all the information, along with some practice questions. So download and happy learning. Thank you for watching this video till end. In this video, we'll learn about quickly downloading the SQL Workbench and doing some hands-on practical examples based on what we learned in part 1. If you like the video, please subscribe to the channel, and in comment section, go ahead and leave a comment of what unique query you can think of that you want to pull from these different tables. And if that query is very unique or very complicated, I'll try to cover it in one of the coming sessions. Until then, happy learning.